Hi, I'm Chris Brown, and this is the fourth lecture in the second part on axiomatic design of manufacturing processes. So what we're looking at here are procedural errors in defining the functional requirements. And this comes from a paper by Professor Kate Thompson of Danish Technical University that she presented here at WPI in June of 2013, and it is published with the proceedings of ICAD, International Conference on Axiomatic Design. So our objective here, and I apologize for not getting the animation quite right, but is to formulate better FRs. So we want to separate FR-like information into more useful categories. So we've been taking a look at the application of categories to different things. And so here we're going to do categorization of some of the design information that is often mistaken for FRs. So we're going to introduce non-FRs, selection criteria, and optimization criteria, and some new abbreviations to remember. All right, some common errors in developing FRs. Now, Professor Thompson was teaching axiomatic design to a large number of students at the Korean Advanced Institute for Science and Technology, and got a lot of experience with the kinds of errors that engineering students can make. But these are also common to errors that practicing engineers make, in my experience as well. And I think this is a very valuable paper, which is why we're spending some time with it. Anyway, mixing FRs with design parameters, mixing FRs with other types of requirements, defining negative FRs. Those are all three things that we need to be able to identify and deal with. So one of the issues too is mixing FRs of the various stakeholders and of the artifact. Now, Kate Thompson uses the term here artifact to mean sort of the product at the end, very similar to the design solution, although the design solution could encompass the whole decomposition, whereas the artifact is just the object. All right. And so different stakeholders may have different views and be trying to design different things. And I've spoken in previous lectures here on confusing the equipment and the mission, for example, as I'm bringing up again here. So are we designing the equipment or the mission? Two different sets of stakeholders, a tool or a manufacturing system. So using the right theme will help focus this. And we've been over themes in the previous lectures here in section 2. Mixing FRs with DPs. So Professor Thompson talks about what and how, the FR talking about what and the DP talking about how. And this is one of the most essential and unique features of axiomatic design, this kind of two modes of thinking about the design, the functional and the physical. So what does it do, and then how can it be done? Now, I often say, what does it look like? Professor Thompson likes the how can it be done. Mixing FRs with DPs. All right. So avoid using use, provide, have in FRs when they're followed out by what turns out to be the DP. So in this case, using a noun that anticipates the physical means for performing a function. So a verb needs to describe the function that should be formed. So rather than say use a rigid frame, you should say support the load. So physical information in the FRs, if we put too much physical information in the FRs, we lose the solution-neutral environment for developing the FRs, and we restrict our design space. And so this will keep us from developing the optimal design. As Professor Thompson points out, this violates the first axiom. And she says it trivializes the mapping process between the functional and physical domain, which is true, because then there is no information essentially added, nothing extra done when you select the physical solution when it already appears in the FR. So it undermines the foundations of axiomatic design theory. But I find this frequently observed in decompositions by students, and it shows that they have not learned sort of functional thinking and solution neutrality, and they haven't quite got the understanding of this. So, mixing FRs with non-FRs or NFRs. What are NFRs? Well, they describe how the design should be. Durable, easy to use, for example, or qualities or attributes that the artifact should have. Inexpensive, lightweight. The character of the artifact, these kinds of things, are needed to ensure that the artifact will be accepted by the stakeholders. Now, the NFRs can almost always be identified by the verb to be. The artifact should be, and then you can put the adjective in, shiny, light, frictionless, something like that, low friction. And sometimes the verb to be is implicit when the NFRs address the user's perception of the artifact. Does it feel smooth? Does it look shiny? Does it smell nice or taste good? So SCs and OCs, selection criteria and optimization criteria. So these will help to determine which of the candidate design solutions should be chosen and where to focus effort to improve the design solutions. So selection criteria. They direct the designer to choose the best. All right. So this might be the lightest, the cheapest, the most robust. So when we're looking to select among the design solution alternatives, then the SCs give us some guidance. So this is similar in a way to axiom 2, which is minimize. Now, the optimization criteria specify which DPs we might try to optimize. Now, these can usually be identified by superlatives, the most, the least, the something ist, IST or EST, or by transitive verbs like minimize and maximize. This is very useful because many times these show up, minimize and maximize, show up in FRs and decompositions. It's not always obvious what to do with them. So negative FRs define what the solution should not do. Often these are customer needs which have not yet been translated into the language of the designer. Or into a good FR, so somehow the customer need gets transported the FRs without being put in a useful form for the design. For example, the artifact should not harm the user. Now this could contain some FRs, like cut the voltage to the panel with the door, when the door is open. My apologies, that should be when. Or they could be containing constraints, like surface temperature should not exceed 35 degrees Celsius, so that nobody's going to get burned by it, perhaps. So there's useful information in the negative FRs, we just need to translate it so that it can be used. And then optimization criteria, like minimize the risk when the user is performing maintenance. So this suggests a little addition to the zigzagging process. So at each zigzag, we would take a look and see about the axioms, which, and I've lifted this figure from one of Professor Thompson's papers. So she's not emphasized the application of the axioms, but so what we're looking at is a kind of foundation of non-FRs, constraints, selection criteria, and optimization criteria that will all be noted, and then we can check the design against those, just like we were talking about against the constraints previously. Now, Thompson criticizes one of my papers, or critiques one of my papers, and so I'd like to take this opportunity to respond to that criticism. First part of the response is, it is apt. I said, FR1 in manufacturing should be maximize the value added to the product, and FR2 should be minimize the cost. Now, it looks like both of these really are optimization criteria, and as I said, I've never really been truly happy with this. So we need to somehow get this information across, and it's not always maximize the value added. And so if we use the key verb here is to be adding something, adding value. So add the required value to the product. So somehow we need to understand what the value equation is from the customer need and translate that into the FR so that we have the right amount of value. And then we want to minimize the cost, and this would be more like a selection criteria or an optimization criteria to minimize the cost of the production process. All right, as I've said before, let's do a quick review. No design can be better than its FRs. So we want to develop the FRs in a solution-neutral environment. FRs must be functional, so keep the physical information out. OCs and SCs are places for quality information. And then Cs are good for things to avoid, constraints. And keep in mind that an FR needs an appropriate DP. It's hard to find a DP for minimize, for example. How do I assure that I've really minimized or maximized something? So if we say, all right, is there a reasonable DP for this? And if there isn't, we should look to see if it's an OC, an SC, or a constraint. And we're better off, to a certain extent, with fewer FRs. Now, if we reduce the number of FRs too far, then we introduce coupling, and we don't get the features we need. Thank you very much for your attention.